In this lesson, we're going to talk about proportions. Proportions mean to adjust or regulate something so that it has a particular or suitable relationship to something else. It can also be when you compare two ratios, when two ratios are equal to each other. So for example, 5/12 equals 10/24 is a true proportion. It's a ratio equals a ratio. More often than not in the real world, you'll see these proportions with units attached to them. So if we look at that other example, 2 inches per 3 hours equals 10 inches per 15 hours is also a correct proportion. When we're dealing with proportions, labeling helps. So generally we want to keep the same units across from each other or on top of each other. In this lesson, I'll keep those units across from each other to be consistent throughout. So we can use proportions to solve problems, but first we need to know how to solve proportions. If we look at an example like 15 halves equals x over 5, when we're trying to solve proportions, we cross multiply, so we multiply on the diagonals. It does not matter which diagonal you start with. So I'm going to start with whatever has the variable. So I'm going to do 2 times x first. That gives me 2x. Then I bring my equals, and I'm going to cross multiply on that other diagonal. So I'm really saying 2x equals 15 times 5. Now 15 times 5 is just multiplication. When I multiply, that gives me 75. Now I have an equation that I need to solve. To get that x by itself, I want to undo my multiplication. And I undo multiplication with division. So I'll divide both sides by 2. That gives me x equals 37.5 or 37.5 as my solution to that proportion. If I look at this other proportion, I have 5 over 22 equals 88 over x. So I'm still going to solve by cross multiplying. Like I said before, it does not matter which diagonal I multiply first. So I'm still going to choose the one with the variable, the x. So I'll do 5 times x first. That gives me 5x. I'm going to bring the equals down, and I'm going to multiply that other diagonal, 22 times 88. So when I actually do that multiplication, I end up with 1,936. Now I need to get that x by itself. I undo multiplication with division, and when I do that, I find that x equals 387.2. Now I said that you can use proportions to help solve problems. So here's some steps to help us solve. First, we want to find out what two things are being compared in the word problem. Then we set up our first fraction using those first two items being compared. Make sure you label this fraction. We write an equal sign, and then we set up the second fraction using our labels to make sure the numbers go in the right place. Then we'll cross multiply and solve. So I'm going to set up my proportion and read through this example. It says Jamie drove her car 99 kilometers and used 9 liters of fuel. How many kilometers can she drive with 12 liters of fuel? So if I look, the two things that are being compared are kilometers and liters. And they give me in this first situation that she drove her car 99 kilometers and used 9 liters. So that first situation is becoming my first fraction. Now, I do want to point out, it does not matter the order that I wrote it. I could have written 9 liters over 99 kilometers and I'd still get the correct answer. Now I'm going to backtrack to our first example with proportions. Notice those like units were across from each other. Inches were across from inches and hours were across from hours. So in this example, I'm going to make sure kilometers are across from kilometers and liters are across from liters. If I look at the second sentence, it says how many kilometers. So I don't know the kilometers, I'll put the X there. Can she drive with 12 liters of fuel? So I'll put my 12 liters there. Now that I have this proportion, I'm going to cross multiply to solve it. So I'm going to do 9 times x, which gives me 9x, and 99 times 12. That gives me 1,188. To get that x by itself, I need to undo multiplication with division. I'm going to divide by 9 and divide by 9. If I do that, that gives me 132 kilometers. If I look at this next example, it says Sam made 3 hospital room beds in 16 minutes. If he continues to work at the same rate, how long will it take him to make 5 beds? So in this case, we're comparing hospital room beds and time. So that first situation tells me that this person, Sam, can make 3 beds in 16 minutes. So I know for that other proportion, I want beds to be in my numerator and minutes to be in the denominator to keep those like units across from each other. It says if he continues to work at the same rate, how long, so I don't know the time, will it take him to make 5 beds? Then I can cross multiply the 3 and the x and the 16 and the 5. 16 times 5 gives me 80. Then I can try to get that x by itself. I undo multiplication with division. When I do that, I get x equals 26.6 repeating minutes. You'll see oftentimes for time, we don't want decimals. So if I round this to the nearest whole minute, I'd say that it takes about 27 minutes. If we look at the next example, it says Mary ran 2 miles in 23 minutes. If she continued at the same pace, how long will it take her to run 10 miles? So in this case, we're comparing distance, the miles, with time, the 23 minutes. So I can write the proportion 2 miles over 23 minutes. And when I set up the rest of the proportion, I know I want miles in that numerator, minutes in that denominator. Then it says, if she continued at the same pace, how long? So I don't know time. I'll put that x in minutes. Will it take her to run 10 miles? So that 10 goes there. I'm going to cross multiply. The 2 times x gives me 2x. The 23 times 10 gives me 230. I need to undo that multiplication, so I'm going to divide both sides by 2 to get x by itself, and I'll find that x equals 115 minutes.